So I decided that I wanted to talk about how I made my list of learning objectives because I found this to be the most sort of intellectually challenging part of this whole task. The details about how I set up the grading or how I gave multiple quizzes, like those were details, but the part that I really struggled with was just articulating what I wanted from my students in the class. So this was a Math 3470. It's a combinatorics class. It's an elective, an upper division elective for math majors. We often have computer science majors take it as well. I chose to implement it in the summer because it's lower stakes. There's not that many students. So if things really went off the rails, there was only, sort of so bad it could go. And it was my fourth time teaching this course, but my first time trying any kind of specifications grading. So I started out just going through my notes from the previous time I've taught the course and the book that I've used. And I just wrote down kind of like, without pausing, I just wrote down everything I could think of that I wanted my students to know. And it came out to 78 learning objectives or outcomes. And I sort of thought, okay, great. Now I have my list. And then I went and talked to a colleague, Stacy Musgrave, who was also in this group. And she sort of became pale and was like, no, that's way too many. You need to cut it down to something like 15. And I thought, well, that's impossible. I can't do that. They need to know all of these things. They're all equally important to me. But after talking to her, I boiled it down to 34. Then I started to write my syllabus and think about how many quizzes I was going to give and all that kind of thing. And then I thought, okay, yeah, maybe 34 is still a little high. And then I had that motivation to get it down a little bit further. So what I wanted to share today was the strategies I used just for taking that huge list I started with and how I brought it down to a smaller list. So I had 5 main strategies, and I'll give you examples, but basically it was consolidation of topics or elimination of topics or kind of moving topics from being a learning objective to somehow being incorporated in the class in some other way. So one example, and you don't necessarily need to know what these things are if you're not a combinatoricist, that's fine, but just to see the example. One example was that on the topic on the binomial theorem, I had 3 learning objectives that I had originally listed, which was to know the theorem, apply the theorem, and then take identities about binomial coefficients and interpret them. And I realized that that's just really 3 sides of knowing the binomial theorem. So I just consolidated that into one learning objective. So that was fairly straightforward. Another strategy that was consolidation within one topic. Another strategy was consolidation across topics. So what I did was I wrote all of my 78 objectives on index cards, and I started sorting them into piles and paper clipping them together. And what I've done here is I've written all of the objectives for chapter 2 in the book that I used, and I rewrote them a little bit to make it more obvious. My original pass through was not quite this obvious. But when you look at these learning objectives section by section, you might notice that there's some that are kind of phrased the same way. So these are all in different sections of the book, but as I rewrote them, I realized, oh, they're really all the same thing. Solve distribution problems about some kind of objects and some kind of recipients. And so I combined all of those into just an overall chapter 2 objective, which is to solve distribution problems, determining a broad objective. And this actually also took care of one problem I had with the idea of sort of tagging questions with learning objectives. Is like I'd often felt, thinking about calculus, for example, if one of my objectives is to use use integration by parts, and then I tell the students, this is the question to test whether or not you know how to use integration by parts, I'm taking away the part of that where I want them to realize that that's the method. And so by making this learning objective broader and including the fact that they need to determine which one of the sections of the book this comes from, I'm also asking my students to use more critical thinking and analytical skills instead of just saying like, here's one with distinct objects and distinct recipients, solve it. They have to figure out what type of problem it is. Similarly, there's 4 here that also have been rewritten here to make it more obvious that are really almost the same thing. Rewrite a certain type of problem from an earlier chapter as a distribution problem. And so I consolidated these 4 into 2 for various reasons, which may or may not be good. I decided to keep the function counting one as its own outcome. I don't know if I would do that again or not, but I took the other ones and I just consolidate them into rewrite word problems of various types as distribution problems. And then finally, the last two sections, the problem or outcomes 4 and 5 now are both about set partition numbers, 6 and 7 are about integer partition numbers. And so I just combine those as well. And so in this way of sort of consolidating and using my index cards, I took the 12 objectives that I had for chapter 2, and I boiled them down to just 5. Now, I also just eliminated some topics. So this is an example: recognize when a relation is an equivalence relation. This one hurt to cut a little bit. I think that this is a super important skill that all math majors should have. But I eventually decided that, talking about very abstract general equivalence relations is not what this class is about. Like, yes, I would like math majors when they graduate from college to be able to do this, but maybe it doesn't need to be done in this particular class. And so I did a little bit of just letting things go. I found that very hard. Okay. And then the fifth strategy, I'm sorry, my phone just rang. The fifth strategy was that there were certain topics that are more advanced topics, and that in previous terms, I wouldn't necessarily teach all of these. I would teach some of them, quote, as time permits, right? And I realized that I didn't need to make those outcomes that were tested on quizzes, but that I could have what I called portfolio problems. So the students were asked to go a little deeper on a more advanced topic. And I actually had 8. I just listed some of them here. And I had an assignment where they would basically have to derive some formulas, write an essay, write paragraphs explaining, how they did the derivation, do some example problems using these things. So for example, with the multinomial coefficients, I had them derive the formula algebraically. I had them derive the formula combinatorially. I had them write a paragraph kind of explaining a diagram that I'd given them, explain how this diagram helps you derive the formula. And then I pointed them to a blog post that used multinomial coefficients in a cool kind of 2-step process, and had them also explain what they learned about there. So it was a more independent kind of thing that they were doing, and it gave them some choice. But these weren't part of my official learning outcomes. This was an advanced project, and every student had to either do 1 or 2, depending on what grade they got. But this allowed me to sort of eliminate these as learning objectives while still making sure that the students got some exposure to them. The final strategy that I don't have a slide for exactly was the strategy 4. I eliminated some things as standalone topics and instead just incorporated them throughout the class. And those in particular were some mathematical practice kind of topics. So things like is able to explain their answers using complete sentences and full justifications. I eventually realized that I didn't need that to be its own objective. That should just be part of getting mastery on every other objective, right? They shouldn't get mastery on an objective of solving a distribution problem if all they do is write down a couple numbers and circle, right? They should have to write down what they're doing and explain it. And so I just eliminated those as standalone outcomes and instead considered them to be part of all of the other outcomes and part of what was articulated that they need for to show mastery. All right, so those are my 5 strategies: consolidation, elimination, incorporating into all of the other outcomes, and then incorporating, instead of being an objective, into these advanced portfolio problems. And so that's all I have. Thank you. I'll take any questions.